I'm Mike Sabota. I'm an application security manager for Amazon's game, media, and entertainment. And one of the things I wanted to talk to you about, or I'm here to talk about, is how we built a DDoS and resiliency testing program for Prime Video to ensure security for things like our live events like Thursday Night Football, English Premier League, and a bunch of others. And where I think this is valuable to you is we spent a lot of time, I spent a lot of time talking about a bit about the process that you can use within your organizations and copy some of these methods so that, you can use within your organization. There we go. So to give a bit of background, we'll talk a little bit about kind of the team, how we're organized, what gaming, media, and entertainment security does at Amazon, how we work with the teams and the developers to actually threat model the infrastructure. But yeah, as part of this, we built a DDoS resiliency and testing program for Prime Video to ensure the availability of live events for things like Thursday Night Football and English Premier League. And what I want to do is kind of jump into that program. I'm going to jump into the overview of the program and talk to you all about some of the things we do, how we work with the developers, what they think about, so that you can understand kind of how we look at threat modeling, the type of metrics we take to show that we're pointing the right direction and we're constantly improving. Some of the things that are important to keep in part when you test, because everything's about testing, and talk about some of the results we've achieved through this program. Okay, cool. That's working.
It's almost like every time I come out here, it goes back off again, huh? Yeah. It's probably me.
So yeah. Games, media, and entertainment security. We're a dedicated security team to help support the various media entertainment businesses across Amazon. So I see some of my friends from Audible here, and we work with Prime Video, Google Games, Twitch, and others. But when you think about how we function, we're actually a customer of AWS and the larger ecosystem, but we own security from what we like to say is glass to glass, and that is literally the cameras at the stadiums to the set locations where we're actually filming and shooting productions, all the pre and post content production up into the cloud to the app on your device. That's kind of the scope of our program from end to end, and we have a variety of functions. So we've got folks that do security engineering. We've got folks that focus purely on things like content security. We have a leak investigations team, so if set locations or scripts get out before a premiere release, we have folks that go and track that down and shore up the leak. We have a lot of third-party and SaaS security teams as well. But I'm part of the overall AppSec program, and our job is to really dive in and go deep where a lot of tooling and scale.
Hey Mike, how's it going?
Good.
I think you got them warmed up.
Good.
You want to start over now that they can see?
Yeah, we can.
All right. Round of applause for our tech team back here to fix that problem. Okay. We're going to get started. Mike did an amazing job telling you what he's going to talk about. Now that you all have those special extra secure goggles turned on, you can see this. Yes, thumbs up from the back. Can you see this back here? Can you hear me back there? Yes, I see a little, it's a shy thumb. Give me a big thumb, big thumb. Yes, there you go, love it. All right, everyone, Mike talking about AppSec.
Okay, so, yeah, I'll continue from where we're at. I think it might be a little bit easier that way. Plus, get this back on lightning talk pace. But our job is to really engage with the developers where it isn't easy for tooling to automate and magically make things go away. So we spend a lot of time working on things like secure by design. We spend a lot of time doing things like application security reviews. Maybe there's new data sharing agreements. We want to get new features to our customers. How do we make sure we do that securely? And then we spend a lot of time on doing things like risk mitigation and acceptance, going, hey, what are the trade-offs trying to deliver this kind of feature? Something like X-ray, if you've all seen it, trying to watch a game. So what does Prime Video's architecture look like, and what is streaming at scale? And Prime Video globally has a couple hundred million customers, but within the US, we see over 150 million US customers monthly. With that, you think of all the devices that we support, from TVs to gaming consoles, tablets, phones. There's 8,000 unique device types across the platform, and there's a lot of long tail to that, and that we've got customers using devices that are over 10, 12 years old, and we've got to account for all those kinds of things in our security constraints and delivering the platform. And when we talk about things like Thursday Night Football, right, that's 18 weeks a year, but realistically, Prime Video's doing over 10,000 events a year across a number of sports globally. So we do things like English Premier League, we've got cricket, we're going to start doing NASCAR and basketball. So this is a pretty high availability infrastructure that has to support a lot of users. And to deliver the services, there's a lot of moving parts. So from just a pure AWS services perspective, the Prime Video infrastructure uses over 60 AWS services, not including all the code and such we deploy on top of it. And that really translates into dozens of development teams and hundreds of developers. And from the services we use, right, by 60 we use a lot. So anything from, we've got a bunch of S3, I've heard SQS mentioned earlier when we were talking services. We use CloudFront, we use AWS Advanced Shield, we use AWS WAF, but we also use some more media-specific services like AWS Elemental and AWS Elemental Media Live. Okay, this is a finicky button. As we dive into the actual streaming infrastructure, like I said, we own literally everything from the cameras at the stadiums through intermediary connects. Some of it goes to third parties, and then we'll do things like ad insertion, and then we get to the distribution layers that's in AWS Cloud that feeds to things like Amazon CloudFront and the various in a number of CDNs. So in a typical Thursday night game, we sustain over 100 terabits of delivery capacity for 15 to 20 million active users. So the volume delivered is pretty high, and it requires petabytes of S3 storage and a ton of compute to do it. If you want to dive deeper in this infrastructure, there's a great Inforce presentation from 2022 that goes into this in depth, in great detail. One of the other things that's really unique about the infrastructure here is that we actually have a proprietary protocol called SI, which is a low latency streaming protocol for delivering sports. And that's one of those other things that we have to take into account as we build and scale these programs. And to do that, as we work with the developers, the first thing we need to start doing is, when you've got all these moving parts and all these people, is we actually go put a threat model together. And for the most part, we use a variated model of Stride, but you can use whatever you want, whether it's Posca or something else. It's really about having a methodical way of looking at all the components so that you don't miss anything. And for this talk, right, we're going to focus on denial of service and related threats. And for that, the first thing we do is we actually sit down with our developers and work to educate them on the kind of the tactics, techniques, and procedures of a lot of the attackers. And we focus on, hey, here's what reflection attacks look like, or here's what CPU exhaustion looks like. And we go through those various components so that they can actually understand the whys and the hows, and have that pattern recognition for the architecture and where the architecture fits together. And this is where, so then we take that education and move to the next step, which is really where the complicated sparks get, and that is actually where the shared responsibility models align. And within the infrastructure, there's kind of three big areas. One is the AWS shared responsibility model, which you think about within the AWS well-architected framework that gives you, hey, AWS is going to cover, the network layer and then, up to the compute, but you own your data. But we also have to develop those shared responsibility models and contracts with like our partner teams, which are the internal service teams that have to work together on who's upstream and downstream, as well as our third parties, because we use a number of CDNs and other resources to deliver these live events on game days. Okay. So really basically, what is something like that? What does something like that look like? And taking a very simple threat model, like, hey, we can just take something like a post-flood, or it could be something like an account takeover targeting a URL. And assume you've got an application load balancer, an Amazon EC2 instance, and Aurora instance as a database. Like we have the teams work together to define a RACI matrix, which stands for who's responsible, who's accountable, who's consulted and informed. So if an attack were to come in or a threat were to come in, who's actually responsible for mitigating, and what does that look like? Are we worried about CPU being exceeded, or database IOPS, or even if it's auto scaling within AWS, right? Who is doing what? Because you need to have all those components mapped out and those contracts understood. We then, from the threat model, actually go into the metrics, because now that we know what we're worried about, we've got to be able to measure it and understand where we're at. And as part of understanding where we're at, I got this quote from one of the development managers, and really it's about having the metrics around the program help them understand what's working and be able to quickly iterate as changes are made, because it was really easy to determine whether they've actually moved forward or backward. And as we dive into those metrics, we kind of have three sort of key areas or core areas of metrics. And one of those are impact metrics. And these aren't necessarily new metrics that you would define for your program. It's like, hey, are my customers having a good viewing experience? And they can be very straightforward things like, hey, how many errors are clients experiencing? Or what does client latency look like? Are they experiencing buffering or pixelization? All those kinds of things are important to know whether you're impacted. So we track metrics around that. The second set is, well, detection metrics. So, hey, did we see a post flood? Did we see, do we see an account takeover attack? And how long does it take to actually detect those types of things? Because this is always a good metric you want to drive towards zero, i.e., our ability to detect is very, very quickly. And in best cases, you'd almost want that negative, such that you're able to detect an attack before it starts impacting or touching your impact metrics. So this is the second bucket of metrics. You want to understand things like, hey, if we actually have to make a change and there's convergence timers, how long do those take to either mitigate an attack or change posture of the environment for delivering a live event? So those are some of the detection metrics we take into account. And then third is the accuracy metrics around all the other things we're tracking and doing. So a good example would be are we getting false positives on detection? So you think of the sine wave of normal traffic. Our traffic looks like that too, except on a game day when we have 15 million users show up for 3 hours, and you get a nice little spike. So you want to be aware of, right? You need to be able to tune your detections to make that appropriate. The other thing that you really look for is, assuming you're mitigating an event, you're worried about things like your false rejection rates or FRR, and that's your good. Those are your good requests that are blocked. These are legitimate customer requests we should have served, but because the way our mitigations were set up, we may have accidentally blocked them, which could cause impact. The other metric that's really interesting that we like to track are false acceptance rates, which are bad requests allowed. And the other way of really saying that is, how much bad traffic did I not stop? And sometimes that's okay, and you can put that in the framework, but ultimately, as long as your impact metrics are good, you're less concerned about things like your false acceptance rates. If your impact metrics are not good, you need to be more concerned about your false acceptance rate and try and drive that down. So with that, so now we've sort of established, hey, what we're looking for, what the threat actors will do, how we're going to measure and detect that against our systems, as well as how our system's behaving. The next thing we really need to do is prove it through testing. And testing's a really key part of this, in terms of testing forces the developers to, and gives them an opportunity to really see and observe their systems with I would say various threats going through it. So this game daying is very important to the process. It also allows the service teams, when we think about that RACI matrix and the contracts upstream and downstream services, to verify their assumptions. One of the big learnings we've gotten from all these examples is you can find a lot of things that work as designed but not as expected. And testing's a great opportunity to determine the difference between the two and figure out an appropriate plan to address. And then third is learning and retention. And with learning and retention, the developers, we actually support the developers in doing their own testing, and we've given them a testing framework and we partner with them. But they do their own testing, so this means they understand how the tools work, they understand how their mitigations work, and they're familiar with them. So if an event were to occur during an actual live event, they know what the knobs do, and they know what the knobs mean, and they can predict the outcome of touching one of the knobs. So that's really one of the big values of testing. But it's important to have testing repeatable. And we test on a pretty regular cadence, several times a year before big events, things like that. But we do keep the testing infrastructure ready to go with known threat models. If you look at late last year, early this year, there were a couple of denial of service vulnerabilities specifically related to HTTP2, like the rapid reset attack. We were able to put those into our testing infrastructure and quickly validate and assert our posture on what this means to the infrastructure and any changes that need to be made in a relatively rapid fashion. The other thing is it allows you to detect drift. That's the other value of testing. Is there's a lot of moving parts. There's third parties. Things change. Testing's a good way to root out changes you may not have been aware of. And then, like I said, it's a cadence mechanism to force the development teams that own these services to stay engaged and coherent with their tools. Okay, so some of the results we've gotten. I've met, and this is specifically results I've taken from the AWS Shield Advanced and the AWS WAF testing that we've done, but certainly increased developer awareness on the threats to their services as well as how these AWS tools behave. Two is by tuning things like protection groups, we've been able to reduce things like false positives on detections, so they're more appropriate for our live event scenarios. And then third, in tuning mitigations, we've been able to actually improve our false rejection rate, and that is good request blocked. So in tuning things like AWS mitigations, we've been able to improve it over 800 basis points through this testing mechanism. So there's a lot of value in putting real traffic through to see how it behaves. So overall, right? Like as you tie it together, delivering live events for Thursday Night Football at Amazon scale is pretty significant. I've talked a bit, how we easily do over 100 terabits for tens of millions of customers in a given 3-hour window, and to ensure that availability and ensure security is where we need it to be. Right, we've spent a lot of time working with our developers on threat models, having clear measuring, having clear metrics around how their services are influenced and things work, and then testing to demonstrate the readiness and that all the workflows behave the way they say they'll behave. So, with that, I'm not even sure where I'm at on time anymore. There's a clock, but I'll be around for a bit if anybody wants to chat. Appreciate everybody showing up on a Wednesday morning.